Aloha and welcome to our video on factors that affect climate. The goals for today's video are to describe how latitude, elevation, and mountain ranges can affect climate, but also how large bodies of water, global winds, and vegetation can also affect climate. So if we look at latitude and its effect on climate, we can see some pretty simple things going on here that we'll look at. Now, just on a basis here, we can see that here in the tropics, we're going to see where it's generally going to be a little bit warmer and we're going to get a consistent amount of daylight all the time. Okay, in fact, on the equator, they get 12 hours every single day. So it's going to be more consistent. You're going to see a lot more sun coming there. As we move to the temperate zones, we're going to see some fluctuations. And then when we get to the polar zones, we're going to see some wild ones where we actually have periods of darkness and periods of all light. So we see that little bit of variation, and that's caused by the tilt of the Earth. The other thing we want to look at is if we notice we have the sun's rays coming in straight at the equator. And what that means is that most of the energy from these sun's rays are coming in and they're striking the equator, they're hitting at a straight angle, so there's not a lot of deflection going on. As we get up north or south, we'll see that the rays are coming in more at an angle, and here we can see how they're just kind of, they have the ability to bounce off a little bit more. So they're getting a lot less of the energy is being absorbed in the temperate zone and even less up in the polar zone because of the slant of the sun's rays. So the north and south of the equator, our latitude function, it's going to vary just because of the amount of sunlight they get at certain times of the year, but also because the rays are coming in more slanted up towards the poles, less of that energy is being transferred for absorption and warming and things of that nature. Okay, in this slide, we're going to take a look at changes in elevation. Okay, and what we're going to use is two cities that are relatively similar in their latitude. Okay, and we're going to use Phoenix and Flagstaff. Now, Phoenix, Arizona is about 1,000 feet above sea level, where Flagstaff, Arizona is about 6,900 feet above sea level. So we're seeing a significant change in the elevation between these two. And what we notice is, remember we said that the higher up we go, the cooler it gets. So if you go up a mountain, it's going to get cooler the higher up you go. So here, if we go to Mount Charleston, it's going to be cooler up in the mountains than it is down here in the valley. So with that elevation change being cooler, we would expect temperatures in Flagstaff to be cooler than temperatures in Phoenix. And that's what we see on our graph here, where Phoenix temperatures are going to be shown in red and our Flagstaff are going to be shown down here in blue. So we can see that difference. Now, precipitation up in the mountains, when the wind blows, we get that orographic lifting. So we're going to see that the winds are going to blow across and lift up. That's going to cause condensation and rain. So we're going to expect to see a little bit more precipitation in Flagstaff, which is what we see down here, than we do in Phoenix. And Flagstaff is going to be in the blue again, and we'll see Phoenix in the red. So you can see that elevation, the higher elevation, we generally will get cooler temperatures, and oftentimes we'll end up with a little bit more rain. Now this slide kind of shows that orographic lifting again. Remember, what we're talking about is we have this air coming in and it blows up against the mountain. As it hits the mountain, it's forced upwards, and as it travels up, it's going to get cooler. We have the cooling, we have the condensation, we have a little precipitation, and then when it gets to the other side of the mountains, the leeward side, then we're in the rain shadow. So what we're going to end up with warm air coming. As the air expands, it's going to get a little bit warmer like that. We're going to be dry air. So it's going to be a desert. And that's kind of what we see here living in the valley, is we have this rain shadow effect going on. Now the other conditions that can affect climate would be water. And remember, we said water has a high specific heat, so it takes a lot of energy for it to warm up. So it takes a long time to warm up and a long time to cool down. So this water is going to act like a buffer. So we're going to see a lot less temperature variation. It's going to be a milder climate. So when you're looking at these islands and things by these big bodies of water, we're going to see a more mild climate for the most part. Now, when we're talking about circulation, what we're talking about are our currents and our global winds, okay? And these are what's going to be moving around a bunch of stuff for us. So when we talked about currents, we could talk about warm water coming in, warming it up, working as that buffer system with the water, but it would be a warmer buffer, or cold water, it'd be a cooler buffer, it'd keep temperatures down. So that's what we're talking circulation, are these currents and things. So if we're on the shore, we have a current coming by that's going to affect the climate. These global wind patterns are going to determine how the storms are going to move and things of that nature. That'll affect climate as well. Finally, we have vegetation. And we all know this one. On a hot summer day, it's a lot cooler to walk across a grassy field than it is to walk across, say, an asphalt parking lot. Vegetation is going to keep things a little bit cool. It's going to increase the moisture of the air, and that relates us back a little bit to this water and this buffer system. So if we have a lot of vegetation, we're not going to see vast changes in temperature as we would if we were in an area that had a little vegetation, like a desert per se. Okay, so that's it for our video. As always, the lessons will go into a lot more detail. Good luck on your quiz, and we'll see you in the next video. Aloha and welcome to our video on world climates. In this video, we'll explain the Köppen climate classification system. We'll briefly go over some humid tropical climates, some humid mid-latitude climates, and then we'll give you some characteristics of our dry polar and highland climates as well. So our Köppen climate classification system kind of breaks it down by humid and dry type conditions. For the humid, we have tropical and mid-latitude. We're also going to have the mid-latitude broken down into mild winters, and then we'll have severe winters. We'll also have a dry kind of climate system, polar, and then we'll also have some highlands as well. So as we look at our map here, you can see from the symbols over on this side where these climate systems tend to occur. We have our humid areas, our wet tropics. That's going to be our tropical rainforest for the most part. We'll have a wet and dry season. That would be like our savannas and things of that nature, where we're going to have a pronounced wet season followed by a dry season, and that can also be rainforests as well. We'll have our, going up to the mid-latitudes, we have our dry summer, subtropical, like around the Mediterranean and the west coast. We'll also have our humid subtropical, which we'll see like over here in China, and we'll see in northern India as well. And throughout most of Europe, we'll have that in a marine west coast kind of environment here. Okay, and these are where we have mild winters. As our winter becomes a little more severe, the further north we get into our humid continental, which would be most of Canada and the north mid part of our country. And then we get into our subarctic, which is going to be northern Canada and Siberia over in Alaska for the most part. Our drier ones will have our steppe conditions and then our desert conditions, and we can see those on the map as well. Our highlands are going to be up in the mountains where it's going to be a higher elevation, and we can get so high that they become very arid and dry, such as the Atacama Desert that we'll talk about a little bit over here. And then polar-wise, we have our tundra where the ground is always frozen, and then ice cap where it's just ice. So that's our Köppen climate classification system, and we kind of went through quickly. Let's take a look at some of examples from some of these areas. So throughout the lesson, they'll go through a couple of these different examples for us. In our humid subtropical, we can see here in China, where we're going to have a pronounced summer, and we'll have a winter, and we'll see these summer rains here. So that's where we're going to say it's humid. There's a lot of humidity. We have that summer. As we get to our dry summer subtropical, what we're noticing the difference between the two. Temperatures, now remember, this is northern and southern hemisphere, so we still have a summer. We still have a winter. Notice that it's not as pronounced, but notice the change in precipitation here. There's going to be a lot less rains coming in, especially in the summertime. So this is where we're seeing that change between these two climate zones. Our subarctic, notice that we have about average precipitation. Is going to be about the same year round, but notice the change in temperatures. We have a significantly warmer summer than we do a winter here. So that's going to show us that there's a severe temperature change. Our marine west coast climate, we'd expect it to be kind of not too crazy. So we're noticing here that our temperature change isn't going to be so severe because we have the buffer of the Pacific Ocean, and then we're going to expect to see an awful lot of moisture coming in off the ocean. So we see a lot of precipitation in this area. And then our continental climate, this is where we're going to experience the greater, again, we'll see this larger change in temperature because we don't have the buffer of any water around us. And then also because the air has traveled across the continent, we'll notice that it's dried out a little bit, so we get a little less rain this way. Okay, so let's take a look at some of the dry climate zones that we have. Here's us, the Great Basin, and we're a desert because we have the mountains on the west coast. So as the winds come across, it pushes up this warm, moist air. We squeeze the water out of it basically, and then we get this dry, warm air come across, and that's why we have our desert conditions here. It's a little more pronounced here in the Atacama Desert. In there, they have much steeper mountains. It actually is so tall that it pushes out. We have so much condensation in the precipitation that we have such dry air there that it's actually the driest place on Earth. We can have other areas like the Sahara here, and that one is because most of the time what happens is our storms are forming here, and these are where our hurricanes come that attack the United States. So our moisture is blowing the wrong way, so that's why we're going to be a little bit drier there. Okay, and that explains our dry climates around the world. Okay, so that's it for this video. As always, good luck on your quiz, and we'll see you in the next video. Aloha and welcome to our video on climate changes. In this video, we'll describe the natural processes that can cause climate changes, but also we'll describe the human processes that can impact the climate as well. So we can look back in our geologic record and we can see that we've experienced differences in climate over time. One of the reasons for this would be plate tectonics, and that would be that quite simply as our plates are moving, they're going to move to a different location on the Earth, and as such we would experience a different climate. So the plate tectonics, the movement of the plates, could change climate over a long period of time. We also have the Earth's orbital motions, and this one's a little bit harder to explain. What we're talking about here is as the Earth is moving around the sun, we have that tilt of 23 degrees. So our Earth is here and we're kind of tilted like this. Well, this tilt kind of wobbles over time. So as it does so, the North Star isn't always the North Star. The tilt's not always going to be 23.5 degrees. It'll kind of vary a little bit. So as that happens, and again, this is over on a geologic time, so it takes thousands of years for this to occur, we can see a change in what the North Star is, but it'll also trigger a difference in the climates of the world. So that's one way that we can change climate, is just by having this wobble on the Earth. Now, ocean circulation, if that were to change, that could change the climate as well. And that's one of the things we're worried about with the melting of the ice caps, is how will that change our circulation of our currents. So we can see where that might be an issue. We can have changes in solar activity. For the most part, it's common, but sometimes we might have a period of activity where the sun's going to be a little more violent, and that would cause a little bit of warming there. And then finally, we have volcanic eruptions. And our volcanic eruptions throw the ash and the dust up into the sky, and that could darken our skies a little bit, basically work like clouds, cool off the Earth, kind of level it out, might produce a little bit more precipitation because we could seed clouds with it. So we can see these variations going this way. Now, the volcanic eruptions is closely related to our mass extinction when we talked about the dinosaurs, because we had that dust layer up there and we saw what that happened. So all of these can affect the climate as we see, and it's all a natural way of doing so. So now let's take a look at human impacts. And human impacts come in the form of carbon dioxide. And what we notice is if we look back in time in about 1850, we notice the start of the Industrial Revolution. This is where we moved from the country into cities, and being in cities, we wanted to have power and light and heating and things of that nature. So we started using fossil fuels, burning wood, and anytime we burn something, one of the byproducts is this carbon dioxide. Now we know that carbon dioxide is found in the atmosphere and it's taken care of by the plants, but what we see in our graph is just an increase exponentially of the amount of carbon dioxide that we're putting out into the atmosphere. What this is going to do is where we have a little bit of unknown. We don't know exactly what's going to happen, how much we can add without it being significant, if we're going to add so much that now we're going to turn the corner, so to speak, and we don't know what's going to happen afterwards. So we definitely know we're impacting the atmosphere. We definitely know we're putting up carbon dioxide, and carbon dioxide is a greenhouse gas. So because we're adding this greenhouse gas, that's why we called it global warming at first. But now we're calling it climate change, and it's not just regular climate change, it's rapid. So something's going to happen eventually. We just don't know how far we have and what's going to happen. Okay, so the lesson will go into this in a little more detail. As always, good luck with the lesson and the quiz, and we will see you in the next video.